So now we're going to continue with our harmonic oscillator. And we started with a mass on a spring, and then we added a damping factor. Now we're going to add a forced vibration. So what is the story so far? You had, let's say, okay, we're going to make the spring go up this time. So if you're building a vehicle or something, you might have a thing up here, flat down here. Here's a spring. We have a damping thing. So like, let's say this is a car, right? There are actually parts like this in a car where something's on a spring. And then there's a damping piston. And that way your car doesn't bounce too much when you're driving on flat ground. So far, your differential equation, this is your force mass times acceleration, is, and we said it was negative the spring constant times your displacement. That was from Hooke's law. And then also negative gamma u prime. That's from the damping. The damping is related to the velocity. Okay, that's on flat ground. What if you start driving on bumpy ground? And what if your bumpy ground just happens to look like a sine or cosine curve? Now there's an external driving force that is going to cause the car to bump more. And the spring and the piston are still going to act to try to make it not too bumpy, because you should be able to drive on hills and be okay. But if it's super bumpy, you might have a problem. So there's going to be the total force. We're going to have one thing added, and this is the external driving force. And this is not the only example of an external driving force, but it is one, a car driving on bumpy ground. So we'll collect everything over here with the u's. And then our f of t is usually going to be something like f naught times cosine of omega t for constants, f naught and omega. So this tells you how big the force is, and then this tells you how much we're oscillating. And then we know how to solve this type of differential equation. If it were homogeneous, it would be second order linear homogeneous with constant coefficients. And when it's not homogeneous, you can use the method of undetermined coefficients. So we'll be talking about equations like that.